I spent the last few weeks overhauling my battery modules, so let's show you what I've done. So here are the battery modules. I've got the 6 of them in the back here, so I've just put 4 in place and the other 2 ready to go in. Now the main thing that I did was in 2 of these modules I found faulty cells, and so I had to replace the cells. So in 2 of these I've completely taken them all apart, put them all back together, replace those cells, put them all back together again. Now, the cells that I replaced them with, some of them were fine, but there were a few that just had tiny little marks on them. And so since I'm not absolutely sure of those ones, I've put those in a defined place. So I've put them at the top 4 of this module here, which is the one that I can get at the easiest when it's in the car. And so that'll let me monitor that one. I've also replaced the aluminium sides with polycarbonate sides, which means I didn't really realize this was going to be the case, but it means I can see them really well. So I should be able to see problems with the ones that I can see anyway. I've done that on all of the modules, and part of the reason I did that is I needed to remove the nuts from down there. That was a problem that I had, was to do with one of those nuts there, and so I removed the nuts from all of the modules, and while I was at it I did those sides there, took out the aluminium sides. So my heating system on these cells, what I've got is I've got some nichrome wire in between cells at various spots in here, with the idea that I can put a voltage across those to heat them up. So out of each module comes these 2 wires. If you measure the resistance across there, it's something like 7 or 10 or something ohms. And then I've connected that up to a laptop power supply. So I found a whole heap of laptop power supplies for free. They provide something like 18, 20 volts. And so that adds up to be something like 10 or 20 watts of heating per module. Now I did it at that rate because I found that I can leave that on all the time and it won't overheat them, but I still do regulate it. I did it at that amount so that it wouldn't ever overheat even if something went wrong with my regulation. So I've got a laptop power supply for every battery module, which means there's one underneath each of these. These 2 modules here will be sitting in here like this, so there'll be one underneath these. The power supplies themselves provide some heat, and so that's why I did them put them underneath the battery modules. Okay, so I've just turned on the battery heating module. What I've got at the moment is I've got a temporary 240 volt going up in underneath the car there. This is because the battery isn't connected. It normally runs off 240 volts when you're plugged in and charging the car. So each of those laptop power supplies, of course, runs off 240 volts AC. And so what happens normally is the AC feeds these controllers here. So they're a 240 volt controller. They're set to 20 degrees at the moment. They've been running all night, so they are pretty close to 20 degrees. I've had them off for an hour or so this morning. They measure the temperature. I've got a thermometer. There's one there, and there's one. Where is it? Oh, there it is, shoved in underneath there. I'll tape them on properly later, but what I've got is one temperature sensor for these 4 battery modules up here, which are all the same size, and one for these 2 here, which are smaller. And so the 2 here will heat up presumably quicker than what the 4 will over there. And so I've got 2 controllers. The front one controls the temperature of these 4, and the back one controls the temperature of these 2. Under the bonnet, also have 2 temperature controllers. There are 2 boxes here with battery module in each of them. This one here has 4 in series, this one has 5 in series. Now this one here has a laptop power supply in it, exactly the same as the back, except it sits on top of this one, not underneath. And this one's a bit different. I didn't have enough room for a laptop power supply in that one, and so I feed that one 12 volts instead. And so I just feed 12 volts from the car system. I decided not to do that for all of them. I used a bit too much power, but that was all I could get away with to power that one there. Now, what that means at the moment is that one isn't heating up. So that one's only at 14.7, 14.1, because it's not connected to 12 volts at the moment. I normally have a 12 volt battery in here, but I don't at the moment because the whole 150 volt system isn't connected at the moment. So why do I heat these cells but I don't cool them? Well, I heat them because it's quite cool here. The optimal temperature range of these cells is, I think, between 20 and 40 degrees Celsius, and they can go down below zero and they can go up to 60. Those are the excursion conditions. So in the winter here, it is quite cool overnight. It's around 0 degrees quite often. The cells themselves in the batteries, as I've been using them for the last couple of years, they'll easily get down to 0 overnight. So that's why I've got the warmers in to keep them up into their more optimal temperature range, more like a 20. In the summer, I turn those warmers off. In the summer, our temperatures here can get up to 30 degrees. Driving the car, my experience, I have found that the cells themselves don't get anywhere more than about 35. I might have maybe seen them 38 once, but they can go up to 60 without a problem. So I'm not worried at all with these about keeping them cool, which is very handy because it can be quite difficult to cool cells. So they're sitting in place now. The timber down the bottom should stop them from moving sideways. Doesn't necessarily stop them moving forwards and backwards, and they're held at the top with when we put the top of the battery box on, they're held up the top there. Now I thought I'd just trace through the voltage to make sure that I've got this right. So down through here we have two wires here coming from the front of the car. So this one here with the red on it, this comes from the right hand side where we have 4 cells. So 4 cells is 16 volts or so, if we say 4 volts a cell. 16 volts at the front of the car. Comes back here, this is plus 150 minus 16 volts. So 16 volts, these two have 5 cells each, so we'll call that 20 volts each. So add it up, so that's 20, 40, 56 volts when we add in the front one as well. So so the way this works, it comes in through here. This is the positive end of this battery module. This is the negative end. And then this is the positive end of the next battery module. And in under here is the negative end down here. So this will connect through to here and will go through to our mid-pack contactor. So that means that 56 volts is always connected together. And so 56 volts is about enough that you probably wouldn't get a zap on it if you touched it. Which means if you disconnect the contactor, you can't get a zap off here because you don't have the 150 volts. So through the contactor, we come to the next one, which is into here. This is the positive of this module, and the negative of that same module then goes into the positive of the next module. So that's connected straight together there. And then this wire here goes onto the negative of that module. So these two have 6 cells, so roughly 24 volts, so 48 volts in that pack, in that 2 modules there. Comes through into this one is the emergency stop switch. So when you're driving the car in the driver's seat there, you can reach behind you and push in the button to stop in an emergency if you need to cut the power for some reason. So that's the next place where we can disconnect it. So if you want to work on this battery, you turn the contactor off by turning off the key, and then you press in the isolation switch here, and you've divided it up into these amounts of voltages that we're talking about. So we had 56 on the first one, 48 on the second one. Then we come out of here and go up to, so in a similar way here, we have positive, negative, positive, negative. So join these two together and connect this wire to these. So another 48 volts over there. And that one goes to the front of the car. And the front of the car has another 5 cell module. So that's in here in the front of the car. This is the 5 cell module at the bottom of the 150 volts. So we had 48 volts from behind there, and another 20 volts here. So we've got 58 volts here. Okay, so 58 volts. So that must be the highest of my groups of cells. So 58 volts is the most you'll ever get. If you push in the isolation emergency stop switch and you turn the key off, and there's another isolation switch here which disconnects. Actually no, that disconnects before we get here, doesn't it? Yeah, this one disconnects before we get to this one. So it's actually 48 volts at the back, and then another 20 volts up here. I added up that wrong up anyway, didn't I? 40 plus 20 isn't 50. Good. And so then that means that this side is the negative of the entire 150 volts, and this side is the positive. So just hooked up the BMS. Here we are here. Now it's working. I'll show you how it's connected up. So I'll just tell you what this means. So this means the temperature, highest temperature is 19 degrees, the lowest temperature is 12 degrees. The cell with the highest temperature is cell 38, and the cell with the lowest temperature is 41. Similarly here we have voltage. Highest voltage is 3.92, lowest is 3.87. Total voltage is 167.3. The cell with the highest voltage, at 3.92, is flicking around here, but 30, for instance, is a common one. There we go, 329.11. There are lots with 3.92. And the lowest, 3.87, is flicking around a little bit as well, but mainly, there you go, 1826, various different ones. Now, the way this works is, this is the master unit here. It sends out a command to the first cell, which sends on to the next one, sends on to the next one, all the way through, all 43, and then it comes back again. Now, so that's needs to be an unbroken loop. If it's broken, there's a fault, and the BMS will tell you where that fault is. And so the way it works is here, let's see, so the message goes out to this box first. So each of the 5 cells in this, then all of the cells around the back of the car, and then it comes back again and goes into this box here. There's 4 cells in here, and then finally back to the master. Now what happens is if you break it, the cells say, hey, there's something going wrong, and even though there's not a complete loop, there should be a loop back to the master from the last cell that had the problem. And so that way the cells can sort of add, the master can add up how many cells are still in the loop, and it can figure out where that break is, and it'll tell you. So we'll go and simulate that now. So I'll just go around the back and we'll follow the lines through. So here's the twisted pairs from the front. It comes along through the green one first, then into this module here, along there, down and back up again, so and back up here, so each cell was connected to the next one up to here. Then this connects via this wire here into the next module, through them, out into the next module, across there, back here, through here, and all the way to the output of this very final one here, and back through the orange and white to the front of the car again. Now what that means is that this is just before the end. So after this, we have another 4 cells at the front. So if I disconnect this, then we have a broken loop, and none of the cells here are in the loop. Hang on, no, that's the wrong one. That was the input, which means that all of these cells are in the loop still. The commands coming from the front aren't reaching here, and so then this first one here that isn't getting the information from the master will say, hey, there's something wrong, send it on, send it on, send it on, and sends it all the way around, which means we come back here and we'll have a fault on the master unit, fault 2, and it's saying module 38. And so if you count up all of those cells that are still in the loop, there are 38 of them. The ones that are not in the loop are the ones in this box here, and there are 5 of them in there. So 39 to 43 are in that one. So that says, so the way you interpret that is module 38 has a problem. Oh, there we go. It's gone fault 0 for there for a second. And then it's decided, no, there's definitely a problem. If we do a different one, so I can connect that again. And that will have rectified the fault back at the master. There's one here that's easy for me to disconnect. So now if you remember, the loop goes around there, which means now it's broken here, which means only these 5 in the back here are still in the loop. There's 5 here and there's 4 in the front, so that should be number 9, I think. There we go, module 9. And so why you want to do this is in case there's a fault, in case you get a broken wire or something, or one of the modules stops working, it's really handy to know which one it is. And so what I do is now while it's working, if I can plug that in, there we go. Now while it's working, I go through and label what the cells are. So here I've got 5 to 9, 10 to 15, etc. So if I had cell number 14 complaining, I know it's in this bank. So something I didn't point out with that BMS rundown, the BMS cells are not in the same order that they're wired up. So the cells are wired up positive to negative to negative to positive to positive to negative, but the BMS goes 1, 2, 3, 4, 5, 6, and then each module, they're not wired up in the same order as the BMS. So although that voltage around the front said 160, 70 volts, whatever it was up to, the voltage isn't connected yet. So it's measuring the volts by adding up all the individual cell voltages. It's not measuring the voltage over the entire pack. With these connections, I've got these little bolts. I'm putting a flat washer on one side. Put that through like so. And then another flat washer and a spring washer, and then a nut. So we have bolt head, flat washer, conductor, conductor, flat washer, spring washer, nut. And with these ones in particular, these and here, this has the 24 volts or so across it. So I should put just something over each of those while I'm doing up these so that I don't accidentally short anything out. I also have heat shrink on my tools to reduce that possibility as well. Most of these connections are copper. Copper's pretty good if it doesn't get wet. It just sort of needs a bit of a a polish up occasionally if there's a little bit of corrosion. Otherwise, I just give it a clean with a rag with methano on it. These ones here are tinned copper. Really good. Generally don't need any cleaning at all, but I do just go over them with a bit of metho because I've had this electrical tape on them, and so I might get the gooey stuff off that. This one here though is an unusual one. This is an aluminium one, and so this one I've polished up and got a very thin coating of electrical grease on there to stop the corrosion. Some of the joiners I'm using are these plated, what would you call this? It's copper underneath, but it's been plated with tin, and there's a few of them. Bit of a lump in the middle which gives it some flexibility, can move back and forth a little bit. Other ones I'm doing are these ones that I've made myself. This is copper pipe, squashed flat, holes drilled in it, heat shrink on it. Doesn't have the flexibility, but it's very cheap. And you can make them to whatever length you need, which is why I've done this one. So I think I'm ready to test this, hook it all up and make sure the voltage is right. If I've got any modules around the wrong way, this should be quite spectacular. So let's see, if I check, you should be able to see that. So if I check from there to there, I should have, what's that, 48 volts or so, 46. So that goes up to the, yep, so it goes up to the isolation switch and then no further. So when I do the isolation switch, that should bring in the next section. Isolation switch is now not isolating. So go from there to there, 93 volts, don't touch that. And the next one in line is through the mid-pack contactor to there. Now the mid-pack contactor requires a battery. I've got the battery in at the moment. It requires me to turn the key on. So that went click. And I should now have lots of voltage between there and there. 132. Okay. Now around to the front of the car. So my BMS is telling me that the voltage should be, what, 167.3. So let's connect it and see what my multimeter tells me. I have this handy spot up the top here to do this test, where I plug into here. So the one final thing left is to pull out this isolation switch. 167.2, that's 167.3, that's not bad. That BMS is nicely calibrated. That means everything's connected. I have voltage. I should be able to charge and even drive.